This is part 2 of the Chapter 1, Lecture 4 material, and in this section we will look at GIS data layers. We'll do this by using an example, which is the challenge of identifying polluting companies and their proximity to populations in poverty, water features, or schools. In other words, this is one of these cases where we're trying to look at the relationship between potential pollution sources and affected populations, and then use spatial data to better understand the patterns of what's happening to those communities. We start out by looking at the databases and map layers. We'll start by looking at databases. The example in the top shows an attribute table that would come from census data. Included in this are the field ID, the shape, STF ID, which is a unique geographic identifier for census tracts, the tract number, median income, the percentage in poverty, and so on. So it includes socioeconomic data from the U.S. Census. And then below that, we have an example, which is an Excel spreadsheet that shows data broken down into columns: city name, SIC code, which is an economic identifier. This would be related to a particular industry, and then a latitude, longitude for location, pounds that may have to do with the use of some kind of material of interest or potential pollution source. And so we then show the data in GIS layers. In this case, we see socioeconomic data mapped out as percentage below the poverty level, and then pollution sources shown by pounds per year, without looking at the details of what particular pollution item we're looking at in more detail. So first of all, this is one of the layers. It's a map that shows the pattern of municipalities in the state. And then we can add other features such as lakes and rivers. We can add the location of schools, and then begin to identify features on the map. So for example, here the Identify tool has been used to identify from a particular layer, in this case pollutants. And the information about that particular location then shows up, and it tells us about it. So it's within the city of Minneapolis, what's the SIC code, the latitude, longitude, and so on. We can also then select features from a map and table. In this case, we're looking at the location of a school that's particularly close to that potential pollution. We can then do selection based on proximity. In other words, we want to identify from a target layer a pollution source that may be close to a lake or river, in this case within a quarter of a mile of a lake or river. We're looking at the Mississippi River there, and a couple of pollution sources appear to be quite close. And in fact, one of them then is selected when the selection is used. Then we could also buffer schools and children within a 2-mile buffer of a polluting company, and we can see there's a fairly large number of potential schools and children who might be affected by the location of those companies. Statistics that we use to support the mapping includes U.S. Census data with census tract boundaries that we could then look at within the pollution buffers. In other words, we could look at the overlay between particular census tracts, pollution sources within those buffer areas, and other factors. In this case, the mean percentage of the total population in poverty in these tracts was 23.25%, as opposed to 9.54% who were outside of these tracts. We can see there appears to be some kind of spatial relationship between people living in poverty and proximity to these pollution sources. The mean percentage of children under the age of 18 living in poverty within these tracts is 26%, compared to 11.74% of those living in poverty who are outside of these tracts. And the mean and median income of these tracts, whose centroid is within the top or multiple pollution buffers, is $29,290, as opposed to a mean median income of $53,690 for those outside of these buffers. In other words, on all three cases, we can look at socioeconomic data that seems to suggest that these census tracts reside in places where poor people are close to potential pollution sources. In terms of schools, there are 25 schools within the top or multiple pollution buffers. The total enrollment of these schools is 1,754 students, and the ethnic makeup of this particular population shows us that it's 1.9% Native American, 7.3% Asian, 25.3% Black, 8.2% Hispanic, and 20.7% white. In general, this supports the idea that there may be racial inequalities found by environmental justice projects when they looked at the makeup of the population that resides near to these pollution sources. We could look further at the census data and compare this to the average for the metropolitan area as a whole or for a county as a whole, and there are multiple ways to then be further analyzed. In terms of particular GIS applications and industries, the tutorial identifies some of the major industries that use GIS. And there's a link here that will be provided on in the lecture area within the course content. So right below this file, you'll find a link to this website for Esri that tells you much more about particular industries that use GIS. And as you can see, there's a large number of them. Some may be industries that you would expect to find, and some may be new industries for you to think about in a